Hi, so in the previous two videos, we looked at differentiating arc sine of x and also arc cos of x. So starting with arc cos of x, we found out that that was negative 1 over 1 minus x squared when we differentiated that. And we found that when we differentiated arc sine, we found that that was just 1 over the square root of 1 minus x squared. So we kind of proved those two results in the previous two videos. So what we want to do now, naturally, the natural progression from that is to look at differentiating, instead of arc sine and arc cos, differentiating arctan. So the derivative of arctan of x with respect to x. And to do this, we're going to use kind of like a similar procedure to what we did when we differentiated the previous two functions. So we're just going to use essentially some chain rule and implicit differentiation to help us get this. So again, same procedure as we did for the previous two. So we're going to let y equal arctan. And then if we apply the tan function, so the inverse of the arctan function, to both sides, we're going to get tan of y equals x. And then the next step that we did before was we now differentiate both sides. So we apply d by dx to both sides. And when we do that, we get the derivative with respect to x of tan of y. And that equals the derivative of x with respect to x. And we know that this is just the number 1 there. So great, yep. So now we know that 1, or d by dx of tan of y, equals the number 1. So what we can do again, like when we differentiated arc sine, arc cos, is we can do the chain rule. So we've got tan of y. So y is a function of x. We know that y is equal to arctan of x. So we've got a function of x inside there, a function of y there. So we've got a function of a function. So that just means the chain rule. So when we differentiate with respect to x, tan of y of x, using the chain rule formula that we've used before, the chain rule tells us that this is going to be d by dx of this function inside the tangent function. So d by dx of y of x multiplied by this outside function, so this tangent function, so this function of y, with respect to the function inside there, so with respect to the y function. So again, that's just using our chain rule. Dy by dx is just dy by dx. We can't really simplify that, but we can work out this d by dy of tan of y. So if you remember from one of the previous videos that we did, when you differentiate tan, you get sec squared. So this is actually just going to be sec squared of y. So we're dealing with the variable y in this case. So yep, so now we know that the left-hand side is just dy by dx multiplied by sec squared of x, and this equals the number 1. So great, now we can get dy by dx as the subject of the formula, because we want to literally calculate dy by dx. That's the objective of what we're trying to do. So dy by dx equals 1 over sec squared. Sorry, I've made a mistake again, the same mistake as the previous video. This should be a y inside there, sorry. So yeah, this is going to be 1 over sec of y all squared. Okay, great, yeah, so dy by dx is exactly the same as d by dx of arctan. So we know in conclusion then that d by dx of arctan of x equals 1 over sec of y all squared, and again the y there instead of an x. But we've got to get rid of this y somehow. So what we've got to do, again, like the previous two videos where we differentiated arc sine and arc cos, we used a trig identity. And the trig identity that we need this time is this identity. So 1 plus tan squared equals sec squared. So we know that sec squared of y is just 1 plus tan squared of y. So we can just put substitute 1 plus tan squared of y on the bottom. And if we go back to one of the previous slides, so tan of y equals x. So tan of y squared equals x squared. So this here is just x squared. So 1 over 1 plus x squared. And so in conclusion then, d by dx of arctan of x is just 1 over 1 plus x squared. And that's it.